So in today's session, we are going to focus on how you map relational data model into what we call relational schema. So basically, we'll discuss how to map ER into a relational mapping. When you discuss this one, there are a few steps we need to follow. So we will start with that one. So last time we discussed about the various different graphical elements we use in ER, starting from entity types, relationship types, and then also a type of relations we call cardinalities, and maximum cardinality and minimum cardinality, and so on. So today we will look at how we are going to actually, use them. Mapping functions. So as you can see, there are a few things we have. So the first step is in the mapping one. We will focus on the mapping regular entity types. Then we talk about how we can map weak entity types and all the relations, starting with one-to-one, one-to-many, and many-to-many. And remember, we are focusing on binary relations. If you have more than two relations participating, then we will also discuss how do you map them. And we'll look at multi-valued attributes. Okay. So this is the example we have considered last time. So you can see here we have couple of regular entities. We have employee entity type, department entity type, and project entity type. These are called regular entity types, and this is weak entity type. The reason for this, like each of these entity types, we can identify key attributes, whereas in the weak entity type, we cannot identify key attribute directly. In this case, we have a partial key. And then you can notice we have different types of attributes are there. So oval shapes we use for simple attributes, and then key attributes are underlined. And then when you have a double lowers like this will represent multi-valued attributes. Here we have composite attributes, derived attributes, and so on. So these are like different types of attributes we have. And then we discuss about the relations. So you can see here we have works for relation, manages relation, works on relation, and even we have a recursive relationship supervision. And you can also notice that we discuss the maximum cardinality, that is maximum participation. So we have one-to-one, one-to-many, and then many-to-many, right? So what we are going to discuss is coming up a logical diagram, something like this. So which is called a relational schema. So in this particular case, all these table-like structures are called relations. So what are the rules that you have to focus on when you are mapping ER diagram into this? That is exactly what we are going to discuss. So let's go one by one. We'll focusing on how we map into this, and then have a exercise for today's work. Right. So the first step is how do you map regular entity types? So each regular entity type, what you are going to do is you are going to create separate relations, and you are going to include all the simple attributes. Okay. So going back to my diagram, so you can see here in employee, we have this is regular entity type, and we are going to include all these attributes. So we create a relation called employee. We include all these attributes. So in this particular case, we can have social security number, birth date, and all the simple attributes. Here, this is composite. We'll use first name, middle initial, last name, then sex, address, and salary. We included for the employee relation. Right. So that's the first step, right? And then we have to define a primary keys. Remember, in entity relations, we don't discuss primary keys. What we discuss is a key attributes. Key attributes means unique attributes. But we have to choose one of the key attributes as a primary key, because we know that in relational databases, you have to have a primary key. So you select one of the key attributes as a primary key, and usually we, underline and that is how we are going to represent. So going back to my mapping one, you can notice here, we have first name, middle initial, last name, social security number. Actually, this is the key attribute we have, and we will consider this as a primary key because this is the only one we had. So up to this point, it's actually coming up from the simple attributes. Right. Now, how do you map the weak entity type? Now, remember I told you weak entity type, the difference is you cannot identify any key attribute. Therefore, what you are going to identify is called a partial key. So in this example, employee, we had a dependent entity type, that is a weak entity type. And what we had was a name as a partial key. So the step of converting this is also the same. So we are going to create a relation for the weak entity type, and then you are going to include all the simple attributes to create a relation for weak entity type. Then we have to consider the foreign key attribute that we have used. So in this particular case, dependent is uniquely identified through the what we call the identifying relationship. And we sometimes call the own entity or identifying relationship. And then you take that key attribute and combining that, you are going to identify the primary key, right? So primary key for the relation will be combination of the owner and the partial key. Right, now let's go back and see how we are going to map this one. So in this particular case, we have this dependent. You can see double lines, rectangle here. And then you can notice here we have used dash line to indicate that it's a partial key. And this is the identifying relationship. Without the employee, there's no existence for dependent. And here you have social security number. So you use social security number and the name together to create the primary key for dependent relation. Now, if you look at the mapping for dependent, you can notice we have employee social security number actually coming from the employee relation, and the name is already there. It's a partial key. By combining this, we create the primary key for this. And these are the other attributes. We have sex, birth date, and the relationship. Okay. Now let's move on. So let's look at how do you map one-to-one relationships. Okay, when it comes to relationships, there are a lot of options, and it's totally up to the designer which option you are going to use. And there are like always pros and cons of each of the techniques. So let's see what are the possibilities you have when you have one-to-one relation. In this particular case, we have one-to-one relation between employee and the department. Employee manages the department. You can work as a manager. So one particular person is managing one department. In the department side, if you take the department, you will have one employee works as a manager. So it will be a one-to-one relation. So what are the steps that you need to follow if you have one-to-one relationship like this, right? For each one-to-one relationship in ER diagram, we have to identify relations S and T for the corresponding entity, right? So as I told you earlier, there are multiple possibilities. You can use foreign key approach. Now, foreign key approach means like you are going to have a one common attribute, and that the common attribute we use as a foreign key, which connects us to primary key of the other relation, right? So in this particular case, choose one of the relation S to include the foreign key in S, primary key. It's better to include the entity type with the total participation, right? Now, if you are looking at our example, what we had is employee, right? We have employee one side. Um, so in this particular case, this is how it look like the particularly the relation. So we have one-to-one relation. So this side, a department can have an employee. In employee side, we have a department. Now, the other point that we want to highlight here is the uh, total and partial participation. So only some of the employees works as managers in the department, whereas the department you have the managers. So therefore, if you read the rule, it says that so you use the entity with the total participation when you use a foreign key. So you can put in the both sides. Your primary key could be put in the other side. So one possibility is you can put the department number is managing the employee side. Then the problem will be there will be a lot of null values. So therefore, the appropriate way is manager's employee number you put in the department side. Okay, so this is how we normally map when you have one-to-one relations. Second one is merge relationship. What do you mean by merge here is like if the two relations you have a total participation, when you have both participation total. So in this particular example, actually, it's only just one participation is total. If both sides, if you have total participation, actually you can merge the two relations. Then the third type is you can use a separate relation. This could be used for any relation, irrespective of whether it's one-to-one, one-to-many, or many-to-many. You will create a separate relations where you take the two primary keys and combining the two primary keys, you are going to create the primary key, right? So this is the third option. So which option? Actually, it's totally up to you which one you are going to use. But merge relation, of course, you have to have both the entity types should be totally participated. Otherwise, you are allowed to use any of the three techniques. In this particular case, actually, we have focus on the foreign key approach, and that's what you will notice. So if you look at the relation is with the employee and the department, and you can notice that manage social security number is used. So what has happened is the social security number is put it here, and this will be the foreign key which connects to the employee relation. Okay, going back to the uh, mapping relations, we discussed one-to-one mapping. So let's look at one-to-many relations. So when you have one-to-many relations, so for example, if you go back to one-to-many relations, you will see the employee can work for a department, but department can have many employees. So the approach that you can use it for this is usually you use if you're using a foreign key approach, you have to use it for the inside. So ideally, we can use the foreign key approach, and foreign key, we put it the inside. In this particular case, one-to-one relation between the employee and then the department. So employee works for the department, and department can have many employees, right? So the inside is the employee side. So employee side, we can include the department number as a foreign key, right? Simple attribute, and then we can use. Of course, as I told you earlier, there's another approach, cross-reference, meaning you can create a separate relations. Next, we are going to discuss many-to-many relations. Again, when you have many-to-many relation, we create a separate relations to separate relation to represent this many-to-many relation, right? So in this particular case, for example, if you take employee and the project in between, if you take one employee can works for many projects, the other side, the project can have many employees. So it will be a many-to-many relation. So the idea is you create a separate relation for this, right? And include both the primary keys, and combination will give you the primary key for the separate relation, right? Right. Let's going back and let's see some of the examples. So in this particular case, earlier we discussed one-to-one, we already discussed. One-to-many, you can say inside is the employee. So when you want to represent the works for relation, so the inside, we take the primary key and put it here. And that's what you will notice here as well. So when you say employee and the department, you can see here we have department number. This is a foreign key, the department number. This is to represent the works relation, right? Using the foreign key approach, we have used it here, right? Going back to many-to-many relations, there are many-to-many relations. In this case, one many-to-many relation, employee and project. So for that, what we need to do is we have to create a separate relation for this and include any attribute. So if you look at here, we have a attribute connect to the relationship. So this will be in the relation we are creating, right? So going back to the mapping one, you can notice we have a works on social security number, the employee and project number. And notice this one, this is actually coming from the attribute connect to the relationship type, right? And combination will create the primary key for this relation. Right. Now, the next one is when you have multi-valued attributes, right? When you have multi-valued attribute, in our case, we have locations for the department. Department can have in multiple different locations. So we call multi-valued attribute. For example, another example would be if you take a particular person, the number of degrees. Well, it could be multi-valued. So each multi-valued A, we are going to create a new relation, and then we are going to include the attribute correspond to this multi-valued attribute and the primary key from the connecting entity type. And then you are going to create the primary key by combining the two, right? So primary key will be combination of A and K. So in our case, it's a location. Let me show you how we do it. So in here, we have a department. We have the department in the number of locations. So this is a multi-valued attribute. So for that, we are going to create a separate uh, relation, and we get the department number and the location. The combination will create the primary key for the department location. Okay, so those are the rules actually I wanted to discuss in the ER mapping. And the last one actually is if you have, like, for example, more than binary relations, right? That means if you have like more than two entity types are participating, then you have to use us create a separate relation, include all the primary keys, and by combining all the primary keys, you are going to create the primary key for that relationship. That is, if you have more than two entity types are participating. Right, that's the first part for today. So let's look at the normalization part, which is one way of looking at whether you are having a good relations. So the direct approach would be you start with the conceptual model like ER, and then you convert into set of relations. But if you want to develop it without going through this, or sometimes you want to make sure that whether you have done this process correctly. Okay, one technique is we can look for normalization. So the normalization is a formal concept of what we call the functional dependencies, multi-value dependency, joint dependencies. And these forms guarantee that your relations are in good quality, right? So basically, there are many normal forms, and we are going to focus on the first three. So by following normal forms, we make sure that at least in the industry level, they expect you to have your relations into third normal form. Right. Now, before we talk about the normalization, we need to understand the concept called functional dependency. Now, functional dependency means using one particular attribute. If you can predict another attributes, we can say, okay, it's functionally depend on other. So when we say, okay, attributes X is functionally determined set of Y, so then given X, you will have unique value for Y. It's something like this. Now, given a city, right, we can identify a postal code, right? Every time we have, let's say, Peradeniya, okay, it can map to a postal code 2400. So, which is every time if it is Peradeniya, then the postcode is 2400. So, which means that we can say, okay, using the city, we can functionally determine the postal code. So this is called functional dependency. Now, in similar way, when you have like unique IDs, like national identity card or passport number, we can uniquely identify each of the person. So whenever you have a unique value for this, then you can determine any other. So primary keys, for example, using any primary key, you can actually uniquely identify the other attributes. So it's very important that we understand these ideas. So in mathematically, if you were to write this, we write the arrow. So in this case, we say X, we have an arrow, and Y. What it means is we can, using X, you can functionally determine Y, right? So in mathematically, if you want to represent the idea, it means something like this. If we have two tuples, we use the term tuple, but it's two records. So given a tuple T1, if you have particular attribute value, right? And if the value is same as in another tuple. So what I mentioned earlier, let's say the cities pair are they need two different rows. And then let's say if you look at the postal code, if they are the same, of course, obviously that's what's happened. Then we can say, okay, we can functionally determine, right? Using X, you can functionally determine Y. Okay. So these are the idea of functional dependency. So if you have two attributes X and Y, take in two records, tuples T1 and T2. If you have same values for X, then you should also get the same values for Y in two different tuples. So if that is the case, we can talk about the functional dependency. Now, some examples using social security, it's like our national ID card. You can determine a particular person's name because it's unique. Similarly, you can use project number. You can determine project name and project location. Every time when you match the project number, you will have same project name and project location. Similarly, you can actually have multiple values using social security number and project number. You can determine how many works particular person works for a particular project. So these are like some relations and how we can represent in mathematical notation. Right. Now, what is first normal form? Now, to say that your relations are in good form, we have different normalization. So in first normal form says that it disallow any composite attributes, multi-valued attributes, and nested relations. So the idea is attributes should be atomic. If attributes are not atomic, then we say it's not in first normal form, right? Okay, let me show you an example. Now, let's say you have, department relation like this. Remember, in our department, we had multiple locations. So, for example, if you think about the values we have, research department, administration department, headquarters, what could happen is you might have in different locations. So see here, we have a research department, but it's in three locations and it's in the same row in the same cell. And what we say is in first normal solve, we disallow this. So you cannot have multi-values. It's not allowed. So therefore, if you have a situation like this, we have to break each and every location into like this. You can see that it will duplicate the department name, department number, and manager social security number. But then by combining department number and department location, we can uniquely identify each of these records. Right. So when you start with A, right, A and B represent the same thing, right? These table structures, the relations are not in first normal. Right. Similarly, you can also see the same thing here as well. In this particular example, it shows you the information about employees and projects together. So what you notice here is you will have employee details and his project information in the same place. Okay, this is not allowed in first normal form. You have to separate it out, right? So how do you separate? Okay, employee social security number and the name, we can separate from project numbers, right? And then you can combine both the project number and social security number together, right? So that you have the access to the same information. Right. Now that we have discussed about the first normal form, let's look at the second normal form. In second normal form, we say it expect fully functional dependency. What I mean by this is, now we talk about the function dependency, right? We normally call all the non-prime attributes. What do you mean by non-prime? All the attributes which are not part of a primary key should be fully depend on the primary key. That's what we call the second normal form, right? So what we mean by this is, now if you have social security number, project number together, we can determine the number of hours. But if you take this individually, you can functionally determine, right? So this is depend on both social security number, project number. But if you have social security number and project number for a employee name, this is not fully function depend on. Using social security number, we can directly determine employee name. So this is called partial dependency, and this should be avoided. So in other words, right, what we are saying that if you are going to say a relation in the second normal form, if every non-prime attribute, non-prime means the attributes are not belong to any primary keys, should be fully depend on the primary key, right? And if it is not, we have to decompose into second normal form. Right, now let me take you an example. So let's say we have employee and project information together. So ideally, if you put these together, what happens? You will have social security number, project number, number of hours particular person works on the project, employee name, project location, everything in the single place. Now we can look for functional dependency. Now, if you take the number of hours particular person works for a project is functionally determined using social security number, project number. So that's why you see this arrow. This will indicate that number of hours is dependent on both social security number and project number. But take employee name only depend on the social security number. And the project name, project location is depend on the project number. Now, the primary key for this relation is defined as both social security number and the project number. So, number of hours is fully dependent, but if you take employee name, it's partially dependent, only one of the primary keys. Similarly, this one is based on the project numbers. So that means your function dependency 2 and function dependency 3 violates the second normal form. What do you mean violates it? Non-prime attributes. Attributes are not belongs to primary key. So this is ours, employee name, project name, project location should be fully functionally depend on the primary key. And it's not the key. Therefore, this is not in second normal form. So you have to break it. So let's look at how we are going to break this function dependency we break. So we have social security number, project number, hours into a separate relation. Similarly, we can take this one, social security number, employee name, and these two based on the project number. And this is how we can separate the relations. Now they are normalized. Okay, any questions up to this about the normalization? Okay, let's look at the next one. Are we clear about the first two normal forms?
Yes,
Okay.
sir.
Yeah. So let's move on to the last one we are going to discuss. So in third normal form talks about the transitive functional dependency. If we can determine a particular attribute value through another one, then we call this as a transitive function dependency. Now think about a function dependency, x. From x, we can function determine y. If we can find out another attribute c, where if we can find out a function depending using x, we are going to function determine c, and using c, we are going to function determine y, then we say we have a transitive function dependency. If there are transitive function dependency, then we say the relations are not in third normal form. Okay, now look at social security number and department manager social security number. I don't know whether this is based on any. Okay, if you say social security number and department manager social security number and transitive, because using social security number, we can determine the department number. Using the department number, we can determine the department manager social security number. So then we say it's transitive functional dependency. But if you say social security number with employee name, it's non-transitive. And there are no attribute we can find out this relation. Okay, I don't know whether it's very clear to you. Can you see here? But before that, maybe we'll discuss. Okay, we discuss this one. We'll discuss this one first. Okay. Can you see the part B? So you can see here in this relation, this is the primary key. All the non-prime attribute depend on the primary key. So that's what we notice here with this and with the arrows. So for example, employee name can be functionally determined using the social security number, and that's what you are getting it. Ideally, when you have primary key, all the other attributes should be able to determine through the primary key. Now, in this particular case, you will see a very interesting one. Department name and a department manager social security number can be determined using the department number. So therefore, when you have like social security number to the department manager, it can go through the department number. So this is called transitive dependency, and this is not allowed. So when you have a situation, when you have a relation like this, we normally call, okay, this is not in third normal form. That's how we say. Right. To break this transitive dependency, now you have to break this into two parts. This part is one relation. This part is another relation. So you can notice now this is fully functional depend on the primary key. Here are also the same. Another example. Right. This is very interesting example. See whether you can understand this. So this about the lots, about the property, and you have property ID, country name, lot number, area, price, and tax rate. What you notice here is this will indicate that from this, because this is a primary key, you can function determine any other attribute. Okay, can you tell me what is happening in the function dependency too? Yes. What is functional dependency too? If you look carefully here, it says using country name and lot number, you can function determine any other. This is sometimes we call alternative key. Actually, we could have used this, but you can have only just one primary key. So this is called a prime attribute. And what are the attributes are not prime, meaning like not a part of primary key. Only we have area, price, and tax rate, right? Okay, now that we have seen, what about this function dependent, ABD3? So using country name, we can determine the tax rate. Okay, this is partial dependency because ideally we have two here to make it a unique. So, and if you refer just one, then we have partial dependency. And here, for example, we have transitive dependency. So if you want to go from property ID, right, to area and from area to price. So it breaks. So your relation is not in third normal form. Sorry, second in normal form. First, you have to break so that you remove the second normal form. So we can break it, right? And now you can notice that everything will be depend on this except for this one, right? So country name, tax rate, we have removed. Then if you look at all the attributes, you have a transitive dependency here. So we need to remove this one as well. So you separate it out so that you remove that dependency as well. And you can draw a tree like a structure if you want. Right. Going back to the final stage. So we discuss about the three normal forms. That rules we are going to use to check the relation whether they are normalized, they are good, right? Without any issues. So for that, there are many normal forms have been designed, and then we consider the first three normal forms.